Hello, we are going to start the concept of Black-Scholes model. So Black-Scholes is derived from the age-old model of Louis Bachelier, which came into fame much later than the death of Louis Bachelier himself, who passed away in 1933. Almost 40 years later, 1973, Fisher-Black, Martin Scholes, and Martin Miller derived the famous BSM model or Black-Scholes-Miller model. This model ultimately gave them Nobel Prize in 1997. This model has faced a lot of rebuttals. This was an option pricing model. It consumes a lot of assumptions like ZCBs are only allowed, dividends are not allowed, European call options can only be priced. However, the good part of this model is that Black-Scholes model is quite accurate if there is no black swan event. It faced a lot of rebuttal in the hands of Nassim Nicholas Taleb, especially after 2007, when Taleb has understood and proved mathematically that Black-Scholes model falls on its face when there is a black swan event, or in fact when there is a Dragon King event. So Dragon King was propagated by Didier Sonnet from ETH Zurich. So these kind of extreme events, whether it is positive or positive from one end, negative from the other end, these kind of events are the events when the Gaussian distribution do not work. Mostly the log normal and the log stable distributions work. These are the events, these are the times when Black-Scholes typically falter. However, we cannot take the negatives of Black-Scholes. In this video, we will learn the positives of Black-Scholes. Thank you. So in this video, we are going to understand Black-Scholes model, option pricing model, which is kind of a basic for all FRM aspirants and all stochastic finance students, and it is extremely important to understand this model. So Black-Scholes model, I will first derive and then I'll tell you the meaning of Black-Scholes model. Then I'll go to the assumptions. And let's first write down the models. So CST is equal to ND1 S minus ND2 K to the power KE to the power minus R capital T minus small t. Let's understand. So C is the call price. K is the strike price. So these basic things I think all of us know, call price and strike price. S is the current price. So S is the current price. You can also derive alongside me, R is the risk-free rate. R is the risk-free rate. N, obviously, as if you follow my old videos, you will know S is Gaussian distribution or normal distribution. N is Gaussian distribution or normal distribution. E, we know exponential. T minus T, capital T minus small t is time left. Time left for exercising. Time left. So suppose it's a 14-day contract and you have entered into it on the 12th day. So capital T minus small t is typically 14, means basically 14 minus 12, that is 2 days. So 2 days are left. Okay. Now this S is at present and K is at future. You have to understand these two parts. This S part is present. This is at present. And this K part, this is at future. So this second terminology is kind of bringing the calculation from future to present. Something like a DCF. All of you know DCF, discounted cash flow. Something like a DCF. So we are bringing the future calculation into present. Otherwise, we can't put it in one equation. That's how the calculation comes like that. That is why K into e to the power minus R to the power T minus T, where K is discounted with risk-free rate. So here, this is an assumption that the discounting happens at a risk-free rate, which may not be true all the time. Anyways, the next part we have to derive. So ND1, the first part, normal distribution of D1 is basically the S, that is the expected value of current price. The signs that you are seeing next to the expected value, that is the expected value sign, that is third bracket. Third bracket, both the sides, is a sign of expected value. For more details, you can see my martingale video. There I have explained it in detail. So expected value of the price multiplied by the probability of S, and which is greater than K at time T0. That is ND1. And for ND2, we have to understand the next term, ND2, the probability, this is also normal distribution with a probability that S is greater than K at the expiry, okay, where small t and capital T equates, that is the expiry. So if I draw, my drawing may not be good, but I'm trying to draw. So if I draw it like this, and this is the midpoint, sigma square by 2, r equal to sigma square by 2, and this is the point where, this is the point where S is greater than K, and obviously the other part of the story, which I am now coloring with orange color, this is the part where typically K is greater than S. So the smaller right hand side part, which is typically the right tail, where S is greater than K, and the other part of the body as well as the left side of the tail is where K is greater than S. That is the entire calculation of Black-Scholes. Now, another important point we have to understand, in Black-Scholes, this D1 is also ln, that is log S by K plus R plus sigma square by 2 multiplied by T divided by sigma root of time. So D1 is from the positive side of the distribution. Now let's understand D2. D2 is from the negative side of the distribution. Therefore, ln S by K, what is S? S is the current price divided by the strike price by K. Now in D2 you will see the difference, R minus sigma square by 2. Sigma square by 2 is a central tendency, so it is in the center. That sigma square by 2 is coming out of R, that means risk-free return. It is, the variance is coming out of half of variance, variance is sigma square, half of variance is coming out of the risk-free return, because it's on the other side, it's on the negative side, that's why it is coming out. Multiplied with T, the total time, divided by sigma root of time. Now Martin Miller, when he extended this model, he gave this D2, he gave it a new name, and which is used now in the stock markets as a KMV model or Moody's KMV model. This is called distance to default. Distance to default. So from one model, another model came out, that is distance to default, which is nothing but D2, which is just nothing but D2. It is absolutely D2. So we will shoot another video where I will calculate distance to default and I will show you how it is calculated in real time. So thank you for watching this particular video. We are coming up with following videos of Vasicek, CIR model, and obviously the calculation of distance to default. Thank you very much. To continue further with Black-Scholes, let's understand the assumptions of Black-Scholes. So first assumption is that whatever is the stock price, call price, whatever is that, whether it is a call price, whether it is a stock price, they follow Wiener process or they follow Brownian motion completely with Hurst exponent at 0.5, which is nothing but random walk. So random walk hypothesis has to be followed, otherwise it won't work. Second concept is that R or RF, that is risk-free return, should be time independent. So it is independent of time and it is a constant. So risk-free return is a constant. The third is there should not be any dividend. There should not be any dividend. So it is a zero dividend model. There cannot be any dividend considered here. The fourth parameter is only European options. European options can be exercised. American options are not exercised. And the fifth is zero coupon bonds to be considered. Zero coupon bonds to be considered. Regular bonds with coupon bonds won't be considered. Only zero coupon bonds are considered. These are the assumptions. And the last and the fourth most important assumption here, that the distribution will remain Gaussian. Distribution will remain Gaussian. That is why sometimes it attracted a lot of rebuttal and critique, especially by Nassim Nicholas Taleb, who said that when we need Black-Scholes model to do the option pricing properly during the global financial crisis of 2008, we found out that it actually calculated in a wrong way, completely wrong way. The reason being that Black-Scholes has all these underlying assumptions. None of these assumptions were satisfied during the global financial crisis. Therefore, Black-Scholes fell on its face. Thank you for being with me and stay tuned for more videos.